Hello, my name's Geoff Burke. I'm a Veeam legend and Veeam Vanguard, and I'm also a Calico Big Cat ambassador. I'm here today to talk to you about data protection and Kubernetes. So, I'm a senior cloud architect at Tsunati. As I said before, a Veeam legend, Veeam Vanguard, Calico Big Cat ambassador. I also have a few certifications: CKA, CKS, CKD, KCNA, and Veeam Certified Architect 2022 and Veeam Certified Engineer 2021. I've been in IT for about 20 years and doing backup and data protection for almost 13 years. So, what's our agenda today? Question comes up often: do we still need backups for Kubernetes? And this comes about because people hear this thing about self-healing, more reliable, and obviously, well, if it's self-healing, then maybe it just heals itself, right? Um, or if we do need them, then why don't we just leverage our present backup solutions? Why do you need something different? What are the differences between virtual and container data protection? How should we protect our Kubernetes workloads? In the end, I'm going to do a quick demo of K3S, leveraging Kasten by Veeam Community Edition. Okay, so the why, what, and how. These are the big questions about Kubernetes data protection. So, Kubernetes self-healing, why back it up? Well, while Kubernetes is very resilient and helps us avoid downtime with things like rolling updates and whatnot, and my personal opinion is it's much better, much more robust than traditional IT workloads. Nevertheless, the same threats are present for our Kubernetes data as were in virtual environments and physical environments. So there's ransomware out there. There are misconfigurations, human error, especially the human error factor I'll bring up because many of us are new to Kubernetes relatively. I've only been doing it for 2 years. And when you're new to something, you obviously are inexperienced and you can make a lot of mistakes. So just on that basis alone, you want to be backing up your deployments. Okay, so organizations do need solid data protection plans. There's no going away from that. The fact that these workloads are better or they're more robust, but they're also complex to a large extent. I think everyone will agree to that. People who especially come from the operations world, like myself, going into DevOps, there is a learning curve, so to speak. So I made a lot of mistakes when I started out, and I still do. So you want to have a backup. Backup is crucial. Okay, so what do you back up? This is a big question because many people don't really understand what Kubernetes is. It's an orchestration system. So, what do you back up? Okay, so in the past, we used backup agents and virtualization backup techniques to back up our systems. So, when there were physical servers, we would just put an agent in there and back up the physical server. Virtualization came along, and then we could use programs like Veeam, which would leverage the hypervisor to do snapshots and whatnot. And the temptation is, well, why don't we just use, an agent or VM backup? So if we have, for instance, our Kubernetes cluster running in, let's say, vSphere, and they're running on separate nodes in virtual machines, well, why don't we just, leverage something like Veeam or some other backup product to back up the virtual machine as we would have done in the past? And there's two major problems with that. The first one is that, as many of you know, Kubernetes cluster is a kind of like live or living organism. There's the API server, it's talking to nodes, there's a lot of things going on. And just to take a snapshot of one node and a second node and then the control plane node, very risky. Things might be out of sync, could be all sorts of problems. Then, of course, there's the other problem of granularity, which we'll get to in a second. So, Kubernetes data protection, I would say, is a little bit more complicated than traditional data protection because apart from the stateful workloads, which are the persistent volumes and your persistent data, there's also a lot of metadata. There are configuration artifacts, things like secrets, config maps, and these need to be natively protected. So you could say that there's a whole new layer of abstraction that needs to be dealt with when you're protecting Kubernetes. So the question is, how then? How do we protect Kubernetes? Um, as I said before, using agents and virtualization backup techniques is how not to protect Kubernetes. Um, if you've got a single node cluster, perhaps that would be okay. Um, but I'll give you an example. Let's say you have a deployment and a MySQL, for instance, and you by accident delete the MySQL password. So your MySQL won't work anymore. So are you going to reinstall or restore the entire control plane, or if it's a single node, just for that one secret? And what if you have other workloads running on that? The entire system will be down while you do a big restore. So granularity is very important, and the only way to achieve granularity, obviously, is to leverage a native solution. So native backup methods are what are required. You need something that understands Kubernetes, understands how it works, and therefore will allow you to restore effectively and quickly too. Workloads also must be protected in their entirety. So we have things like persistent volumes, as I said before, configuration maps, secrets, all sorts of things. And these have to be seen as one entity. And these can, of course, as you know, workloads are spread across different nodes if you have a multi-node cluster. And so you need an application, a backup application that understands this and sees this. This component is the same for previous backup techniques and present ones. You need an offsite DR component. There's no getting away from that. I think everyone realizes now we've had so many disasters in the last few years from COVID and everything else that we have to think ahead. And obviously, having your data in one location simply isn't good enough. In Veeam, there's the 3-2-1 rule, which actually has been expanded. It means 3 copies of your data. 1 is production, 1 is your backup, and 1 is sent off site. Very important. And 2 is the 2 different medias, and 1 is off site. So you must have an off site. And that DR component can be something that can be restored off site or just kept there for archiving purposes. It's another possibility as well. Okay, I want to do a quick demonstration. And what I want to show you in this demonstration is everything I've basically talked about. So I'll just switch over to my setup here. Now, first of all, what I will show you is, I'll clear this off. I have a small K3S installation. And with K3S, it's going to be properly is the leader in edge Kubernetes. And so we get requests to back that up. And so what I'm going to do is take a default K3S. So by the way, the instructions to do all these steps and to set this entire system up are on a link, which is in the presentation. So if you go to that link, you'll be able to recreate this entire simple, but nevertheless functional demo environment. And you'll be able to look through this yourself and understand the concepts better. So all I have here is a single node cluster, a K3S, which I installed just with one command, and it's running. I also created a application. So I'm going to get my namespaces. This also has Rancher on it, by the way. So Rancher is a kind of GUI on top of K3S that you can use. But I'm doing the basic to show you what I'm up to. So I have a deployment in a namespace called Nginx. So let's see what's in there. Let's see the pods in there. Next. Okay, so there's one pod running with 2 containers, and it also is stateful as well. So we can just take a look and see Nginx. So it has 1 persistent volume claim, not very big, only 1 gig, and that is in my deployment. Okay, so what did I do? Well, I installed the free community edition of Kasten by Veeam, and I leveraged that in order to take a look at this and back it up. And the beauty of this is it'll show us everything that all the things I talked about are included in this. I'm just going to switch back to this. Okay. So when you install by default Kasten by Veeam, generally it wants to do snapshots, and the snapshots are local to your Kubernetes cluster. So they're not really backups. This is similar to the virtualization world where snapshots are considered, well, you do them beforehand, in case there's an emergency, but it's not really a backup. And with Kasten, what we can do is export these snapshots if we're using snapshots, or we can even do generic backups. And I'll explain the difference between that. So to do snapshots in Kubernetes, you need to have a container storage interface driver, and you have to have volume snapshotting enabled. And that's not available everywhere. And when you install default K3S, it's not there. You can add it on depending on the type of storage you're using. So if you're using Longhorn, for instance, there's instructions of how to enable the CSI snapshotting driver, but it's extra work. So by default, that's not there. Doesn't mean we can't back it up. And the way we do this in Kasten, I'll bring this up again, is we will just install Kasten, and this is in your instructions, by the way. We install Kasten with, with a generic sidecar injection. So what do I mean by that? Well, what happens is when our deployment is placed in our namespace, we can annotate the namespace, or label the namespace and say, okay, inject a canister sidecar here. And canister is an open source solution. And what's going to happen is it will then be able to back up a generic volume without using a snapshot. Now, this sounds complicated, it isn't. And the end result is, I just wanted to show you there's two ways of backing up. You can use snapshots or you can use generic. I'm using generic in this case simply because I did not bother to go and install a CSI. Most people wouldn't if it's just a small installation. Okay. By the way, the instructions to install this are in the file on the URL. So if you get stuck and think, oh my goodness, what's he talking about? It's in the URLi. So you'll be able to follow it. Very simple. Just copy and paste and you'll have the same system up and running. Now, in Kasten, when you install it, what will happen is by default, it will look and show you all of the namespaces that are available in your system. So again, this is an application which understands Kubernetes, understands, how things are organized and segregated, whatnot. So here I can see everything. Now, as I told you before, I was playing around with Rancher, and so I used the Helm install for Rancher. So there's a lot of Rancher stuff in there, but I'm interested in this one here, Nginx. Very small web server, and with some persistent volume. So it's got, so if I restart the deployment, the data will still be there. And all I did in Kasten was I created a policy by pressing on this, create a policy, and then went through the defaults. And in the end, it gave me this one backup policy. Okay. Now I put snapshot on demand. However, this can be scheduled, obviously. I just did this for our purposes. Now, the important thing here is that we need to send this offsite. Now, what I did here, and you'll do too if you follow the instructions, is and you can do this a lot in Kubernetes, I emulated offsite locally. So I created a Minio S3 compatible system on my local cluster. You don't want to do that if you're doing real data protection, because you'll be, in a sense, backing up to your own cluster. So if you lose your cluster, you're not going to be in great shape. So I'll just show you this. Get NS. So I've got created the namespace Minio. Get po n Minio. Minio is very convenient for these little tests and things. It's actually very good for real production as well. I highly recommend it. But for these simple tests, it's fantastic. So it's just one pod running, and I have a node port service, so I can connect to that, the node port service. And if you want, we can even see, I believe, I think I closed it. Or did I close it? Let me just take a look. Yeah, I did close it. Anyways, we could have got logged into the Minio and seen the actual bucket and whatnot, just to show you, prove to you that it's there. However, in Kasten, what we do is we add this as a location profile. And a location profile is something, obviously, in a location, and so it's somewhere else. And as you can see, it's generic S3. I named the bucket Kasten, and my backups will go directly to this. And this would normally be offsite. Okay, so let's go back and take a look at the backups. So my policy is there. I've already ran one successful. I had one failure when I made a mistake. As I said, that's one reason when you want backups is because we're all new to Kubernetes to some extent, and we're going to make mistakes. But this one was successful. And if we take a look at this, you can see that it's we can drill down a bit here. It'll show you the phases of what it did. It will show you, in this case, I used a canister, which is generic backup. It didn't use an actual CSI snapshot, but it did a generic backup, which can be used on any type of storage. So if you have storage that doesn't support CSI, you can do that. And as I said before, by default, K3S just has local path if you install it by default. So this is the system we're going to use. Now, when I was talking about the differences in Kubernetes and traditional backup, right here you can see in the spec, it's showing us everything that it's backing up. So namespace, secrets. I talked before about deleting a secret by accident. Config maps, very important. Storage classes, deployments, and not least, what you call last but not least, persistent volume claims. This is your storage. Now, when containers were first brought in, I don't even think there was persistent storage. Everything was ephemeral. And so if you restarted your container, basically your system restarted with everything new. This was fine for things like static websites or anything that was a static application. However, obviously for databases or any kind of website which is dynamic, that's no good, because obviously you're going to have data that we're going to want to keep. And so this become a major change, and this is one of the main targets that you want to go for when you're doing your backups, obviously, apart from all the configuration. And the beauty of this backup is that you can restore anything individually. So what I might try to do right now is I'll go back to the dashboard. And as you can see, what I like about Kasten Community Edition, or Kasten in general, is that it's very intuitive. I actually showed this to salespeople who, they sell backup, but they're not deep experts or technical certified wizards, whatnot. And this was not difficult at all. These are intuitive things, applications, policies. You don't have to be a Kubernetes genius to figure this out. So what I do like about it, though, is that you can go deeper if you like to. So again, this is where you run the backup. In fact, I'll show you the actual, what it looks like in here. So it's all very straightforward. Nothing really complicated here. If I was using CSI, container storage interface, with volume snapshotting, I could enable backups, snapshots, exports, and that would export those snapshots. Kasten can do that as well. But in this case, I'm using generic, so just taking the data out through a sidecar and sending it off to the S3 location. And you can see here, location profile for canister actions. Canister does other things too as well. There, you can deploy blueprints for your applications, and blueprints are things which will allow you to do things like to freeze and then thaw a database. So these things can be done in traditional backup as well. And people will ask that question: well, what do I do? How do I get application consistency? I mean, a database could be always running, even if it's Kubernetes. That's something that hasn't changed between virtual, physical, and Kubernetes backups. So this canister application will allow you to create a blueprint. There are some default ones in there, by the way, like MySQL and Mongo, things that are very well known, and allow you to perform these kind of operations. Let's just go back here. So that's obviously very important. Oh, I was there before. Alrighty. So what I want to do now is go to here, and I'll go to the next page. Okay, so I only did one backup. Obviously, if this was production, you'd have a lot of backups, hopefully. To restore, you simply go to the restore button. Again, very intuitive. And when I press this, we're talking again about native. Why is this important? Well, because like I said in my slide demonstration, what happens if you just deleted one thing, like a secret or config map? You don't want to use a VM backup job and reinstall the entire node, or I mean, if you have multi-node, I don't even know if that would work. You'd have to reinstall your entire Kubernetes cluster of multiple nodes and control planes, which would be a lot of fun and a lot of time. That was facetious fun. It wouldn't be fun. So what you can see here is here's restore, and I can deselect volume snapshots. Okay, it's not going to restore the volume. Okay, And then let's just deselect everything. And let's pretend, in fact, I could do that right now, delete this, but we can overwrite it. So let's say I delete the secret. Okay, I was being silly. I deleted the secret. I want to restore just the secret really quickly before my boss finds out that I was playing around production. So I will just restore the secret. So I'll press restore. It's going to say, okay, this is a partial restore, including 0 volumes, artifacts, 1 of 6 spec artifacts. So that's the beauty of native data protection in Kubernetes. Okay. And because it's just a secret, we'll go back to the dashboard to see what's happening. Because it's a secret, this should be relatively fast. Oh, look at that. Oh, that was the backup. I'm sorry. Oh, but there, boom, finished. Okay, just like that, it restored my secret. Whereas if you were going to use a VM restore, you could be up to an hour or whatever, depending on how big it is, and that would be downtime. So that's a perfect example of restoring a secret. There are some other interesting things that you can do too, which again require that you have a native application for Kubernetes backup. Kasten's one of them. There are others too. I just happen to know Kasten very well, but whatever application you're looking for, you want to make certain it can do this. It has this kind of granularity. I think most that are Kubernetes focused should. Okay, let's go back to restore again. I want to show another interesting thing. So you can go through all these things, but there's something that's specifically interesting in Kubernetes, and these are transforms. Okay, so what are transforms? Well, let's say you want to move your workloads. So let's say that you've got an AKS deployment or a deployment in AKS, which is the Azure Kubernetes offering. And I don't know, perhaps they've raised their prices or something like that, and you want to move out of it. Okay, it's not that easy to move deployments because things, especially like the storage classes. Okay, so we talk about storage classes. We'll go and take a look. Get my thing up. Okay, so what do we have here? Clear this. So by default in K3S, we have local path storage class. Okay, so, and I've got my, take a look, make sure I'm not lying. Nginx. So here is our Nginx. Okay, Nginx deployment running there, fantastic, and it's running with the storage class of local path. Well, let's say I want to move this to AKS, or I want to move this to something else, or whatever. Okay, I have to change that. Now that sounds easier than it is, but with our Kasten deployment, we can do that quite well by leveraging a transform. So I can add a new transform. And transforms can be done on many things. They can get very complicated. So I wouldn't go into that. But what they have here at the top is use an example. And there's a couple examples. One scale deployment and one is change storage class. Okay, so just what we were talking about. So I could press change storage class. It's going to apply this to what? Well, obviously to the persistent volume claim. And it will set the value. Now, by default, it's going to replace this. You have to go in and change this because by default, it's coming down to something like an AWS kind of thingy, SSD, US, West 1, whatever. So I would change that to whatever my value is going to be in the future. And you can test the operation, you can do it, and then that will, you could point this to your AKS or to your other cluster, and automatically it will transform the storage class into the storage class of your new cluster. Very effective. Now, another interesting thing here as well is scale deployment. We're going to discard those changes. So scale deployment. Now, you're going to ask, well, why would you want to scale your deployment? That's a very easy thing to do. Just K or kubectl scale deployment, replicas equals whatever, 5. Okay, yeah, it's true. But another added value of using a Kubernetes native application for your backup and disaster recovery is you can perform replication. So you might have a local cluster here, and you'll have a very similar cluster in a different environment, offsite, somewhere like that. And you want to do constant restores, which you can do with Kasten, for instance. It's done by creating import jobs. And so you have a backup job taking place here in this instance, And then you install Kasten in a offsite location, and you have an automatic import job. And you point them at the same, let's see if you can guess it. Yes, location profile. Another reason why this location profile has to be somewhere else. Now, it can be in your data center. That's not a problem. But what you can do then is you do your backup. Okay. It goes to this MinIO. Could be in your DR site, could be somewhere else, could be an S3 if you want to use AWS, AWS S3 or Azure. And then you have another Kasten set up in your DR, which also has the same location profile like this, but it has, instead of a backup job, it has an import job. Okay. And if we go to our policies here, you can create a new policy, and you see there's two actions. There's snapshot, which is backup, but there's also import, and you can schedule that. So what you would do is, from your main location, you have a backup, let's say at 10 p.m. You see how long that takes. And then let's say at 2 a.m., you have an import job at the other location, grabbing that data to your new location where there's a cluster running. So back to the transform about scaling. Well, if you've got a huge workload, you don't want two workloads running at the same time. And by default, well, if you just import, it's going to import the way your cluster is. So if you've got, 10 replicas running, it'll run 10 replicas. So how to save resources, which means save money, you do an import with a transform and set the replicas to 0. So what will happen is your backup will take place on your production site. The data will be sent to the S3, and then the import job will import from the S3, but will transform the deployment to 0, to scale to 0, which means it's using no resources, whatnot. And that is a form of replication in a sense, because you can easily, if you have a major problem at your main site, you can easily just go in and scale your deployment back to 5 or 6 or whatever replicas you need. So that is a wonderful way or technique of doing this. And again, it's all on the basis of knowing each artifact in Kubernetes, that's how it's done. You could also install other things as well. Okay. On that note, I think I will finish. See, I got a slow connection. I've been doing too much. This is my local test system. Thank you very much. If you have any questions, please contact me, Geoff.Burke@Tsunati.com. And have a great day and enjoy SUSECON. Thank you very much.